Okie dokie. So there are special products, and there's like two things we do to them. We either multiply or we factor. And so I'm covering just the multiplying part. If you understand the multiplying, and then factoring is like reversing it, and then you can kind of see how the factoring goes. I think it's easier to actually learn the multiplying versus the factoring and then understand that they're kind of backwards. So these special products are particularly polynomials. So we do need to understand what a polynomial is. So a polynomial in the variable x is a finite sum of terms in the form ax to the n. So we break down this definition. We've got our variable x. Finite means that it does not go on forever. So we have a set number of things added together. And the form ax to the n just means that you have exponents on your variables. So you're going from highest to lowest, and you've just got a series of terms with variables with exponents, and you count from the highest exponent down to the lowest exponent. And that's what makes it a polynomial. So the key about polynomials is that we have no variables that are in the denominator of fractions. We have no variables that are inside radicals, like square roots. There's no variables inside absolute values. There are no variables that have any negative exponents or any exponents that are fractions. So the variables just have whole number exponents. And some terminology with polynomials. So the word poly means many, and nomial basically means term. Many, I think it comes from many named. And so you just got many terms together. And if there's one term, we call it a monomial. Two terms is a binomial. And then three terms is a trinomial. So the prefixes here are very common prefixes used for 1, 2, and 3. Like bicycles have two wheels, so binomial 2. You've got trilogies, there's 3 of them. And we just had the Olympics, the Winter Olympics that finished. And one of the newest things at the Winter Olympics is called the monobob, it's a bobsled with one person. Usually bobsled has 4. And so they actually had special bobsleds with one person. They called it the monobob. So, which is a very interesting name. But mono basically means one there. And then anything that has more than 3 terms, we don't have a special name for it. It's just a polynomial. And I'm bringing this up because when we're going to be doing these special products, we do them specifically with binomials. We're going to be multiplying binomials together, and then the result is going to be a binomial or a trinomial. So we're going to be focusing on multiplying here. And there are basically 4 ways that we can do this. There's the vertical method, which the book does cover, but I do not like, and so I don't use it. We have the distributive property, which is like the other terms are using the distributive property. They're just different ways of writing what we're doing, but you can do it with the distributive property, which is like the technical way to do it. There's the table method, and then we have FOIL. So we are going to be using FOIL because we're going to be multiplying binomials, but because these are special, we're also going to have some shortcuts, some ways that you can get to the answer without going through the whole FOIL process. So we're going to be doing FOIL and then use the shortcuts so you can compare them, and then you can kind of see which method you prefer. So since we are going to be using FOIL, you need to know what that stands for. So FOIL is first, outside, inside, last. So I've got them color coded here. The first stands for the first term in each set of binomials. Then you multiply the outside terms, the 2 things on the outside. Then you multiply the 2 terms that are on the inside. And then you multiply the last term of each set of binomials. And it makes what I call a FOIL face, because it makes a face when you kind of move all of your arrows and everything that you're matching together. So it only works when you have two things times two things. So for these special cases, FOIL always works because we're going to be using two things times two things, but we're also going to be looking at the shortcut. So these are the shortcuts for these special cases. And we call them special products because the word product means multiply. So these are special multiplications of binomials. So we have the product of conjugates, which results in what we call a difference of squares. And so if you look at that, you're multiplying two binomials together that look identical, they just have opposite signs. And when the result of that is going to be something squared minus something squared. So the minus is a difference, so it's literally a difference of squares. And this special case is the one that I recommend that you memorize. Difference of squares is so important. It shows up a lot with factoring and multiplying. So you really want to know how to multiply it to get to the difference of squares and then go backwards and factor it, because that is going to show up a lot. Then the other one we have is what's called a square of a binomial, where you have something and it's squared. And this is where people tend to make mistakes. So I actually recommend that you stick with FOIL for those, because people tend to make mistakes when they try to use the formula here to find it out, or to find it. But we will use the formula as well. We'll do both. But you end up with what are called perfect square trinomials. Now, seeing a perfect square trinomial, it's a little more important when you're factoring versus multiplying to be able to tell that that's what it's going to be. But the difference of squares is really important. So that's the one you really want to focus on. So we're going to be using these formulas, and then we're going to be doing FOIL so you can see why the formulas work, because you'll see it, we'll work it out with FOIL, and then you'll see how we get that formula, and then we'll do the formula. So sort of kind of makes sense, and you'll see where these formulas came from. So I'm going to start with the difference of squares. So this is a difference of squared here, or it will be a difference of squares. These are conjugates. And we use the word conjugate when they are the same thing but opposite signs. So they both have a 4 and a 3x, just one is a positive, one is a minus. So those are conjugates. And when you're multiplying something like this, so a plus b times a minus b, you're going to get a squared minus b squared, which is our difference of squares. So first, we're going to do this with FOIL so that you can see what is actually going on. So we have 4 plus 3x, and then 4 minus 3x. So FOIL, you're going to multiply the first things together. So that's going to be your 4 times 4. So that gives you 16. You can multiply these in your head. So that's the first term. Then you do the outside. So that's going to be the 4 times negative 3x. So you do 4 times negative 3, and that gives you a negative 12, and then you have an x. And I separate each of these with plus signs. Then we are going to have the I, which is the inside. So that's going to be this 3x times 4. So you're going to do 3 times 4, which is 12, and then you have your x. And then your last terms, which is the 3x times the negative 3x. So we have 3 times negative 3, which is a negative 9, And then x times x is x squared. So when we do FOIL, we end up with 16 plus negative 12x plus 12x plus negative 9x. And so when now you want to combine your like terms, and the insides here, there we go, there were the insides, negative 12x plus 12x, those cancel out because negative 12 plus 12 is 0. So those disappear. Those are no longer there. They're just gone. And so then we are left with our 16. And then we have our minus 9x squared because the insides cancel. So our answer is 16 minus 9x squared. And so that is a difference of squares because 16 is a number squared, 9 is a number squared, and the x is squared. So everything in our answer is something squared. And we've got this minus, this difference of squares. The minus means difference. So we've got this shortcut where it's a squared minus b squared, because the inside things end up canceling out because they end up having opposite signs. So if you're looking at the top right where I have the formula, you can see that we don't have a third term. It basically went to 0, it disappears. So if we were to do the same problem using our shortcut here, so we have 4 plus 3x times 4 minus 3x. We kind of want to identify what our A's are and then what our B's are as part of the formula. So the A is like the first thing in the formula and then the B is the last thing. So A is equal to 4 and then B is equal to 3x. So our formula is A squared minus B squared. So A is 4, so you have 4 squared, and then B is 3x, so you have 3x squared. And then you square that. So now you're using your rules of exponents. So 4 squared is 16 minus, you square the 3, which is 9, and you square the x, which is x squared, and you get the same answer. So the left side, we had to go through FOIL and we multiplied multiple things together. We added our like terms and we got our answer. On the right, all we needed to do was multiply the first and the last because by using this shortcut, you recognize that the outside and inside cancel out. So you're basically doing half of the work. And so while it looks like it's taking the same amount of space here for right now, what usually, if I do FOIL, I write out all of my steps like I did. I write down all 4 of my things that I multiply together. But if I do the shortcut, I don't need to write anything because I can go straight to the answer because you can do that multiplication in your head where you can square the first and you square the last and you don't have to do any adding or subtracting. So there's no intermediate steps there. So the benefit of the shortcut is that you can basically get your answer in one step. And that's really huge because we're doing factoring this week. We're going to be doing factoring next week. We're going to be doing factoring in week 5. We'll do factoring in week 6. We do factoring in week 7. Basically, every single week going forward, we're going to be doing factoring. So recognizing that something multiplies to a difference of squares and having that memorized means that when you have a difference of square, you can also go the other way around and factor it really quickly. So you really want to be able to look at something that's set up this way and know what it multiplies to, because then if you can do that instantly, basically just have that memorized in your head, what it looks like, then you can also go the other way around instantly. And it's going to save you a lot of time for the rest of the class because the difference of squares really does show up a lot. So are there any questions? Okay, so for the quiz, how do I prefer you show their work? Either one is fine. So you can do FOIL or you can do the shortcut. If you do the shortcut, usually I don't require you to show any work because I know what you're doing. You're squaring one and you're squaring the other. Because it's something that if you're using the shortcut, you can basically just do in your head. So you can do either one. I encourage you to practice with the shortcut just because it really is important. But either one will be okay. You don't even need to do it in your head. Just write down the original problem and then write equals and then the answer. So if I was to do this with a shortcut, I would write 4 plus 3x times 4 minus 3x. And then underneath it, I'd write 16 minus 9x squared. And that would be it. You don't have to write that intermediate stuff. And that would be good enough because it is literally like one step when you're doing it that way. So I've got a second example here. This is also I have a typo. It's not exactly the same. We'll make this a 3. There we go. Okay. So now these are the same thing. You know, it helps when I actually type it correctly. So we've got 4x cubed minus 6 and 4x cubed plus 6. So we're going to go through FOIL, and then we're also going to use the shortcut again so that you can see both ways. So when I do it with FOIL, I'm going to start by rewriting the whole thing. And then I write down each thing. So we have 4x cubed times 4x cubed. So some people, when you have something a little bit more complicated like this, will prefer to actually write that down before, instead of doing the multiplication in their head, just because once, you know, it's one thing if you're just multiplying two numbers together, but when you start throwing in those variables, sometimes you're more likely to make a mistake. So writing down what you're multiplying and not trying to do the multiplication in your head is sometimes a benefit. So it kind of depends on where you're at. If you're able to do it in your head, great. If not, write it down. So I'm going to just write this one down because it is a little more complicated with that x cubed, that people are more likely to make mistakes here. So then we're going to multiply the outside. So that's going to be 4x cubed times 6. And this is definitely going to move into my right side with the shortcut, but that's okay. Then we've got the inside. So I've got a negative 6 times 4x cubed. And then we've got the last terms, which is a negative 6 times 6. So if you are one that likes to write it out like that, you can. And actually doing it this way, you can see that we have this 4x cubed squared right there. And like we have here, it's a minus, and then you have a 6 squared. It doesn't look like it because we have minus 6 times 6, but it really is the same thing as multiplying 6 by 6 and then having that minus there. So you can see where the shortcut comes from when you write it this way, because you can kind of see your things are squared, but you know, normally you're not going to actually write that out when you do the FOIL. You just multiply. So we've got 4 times 4, which is 16. And then when you multiply your x's, you add the exponent. So that's going to be x to the 6th. Then 4 times 6 is 24. So I have 24x cubed. Then negative 6 times 4 is a negative 24x cubed. And then negative 6 times 6 is negative 36. So your middle terms will cancel out. And we will get 16x to the 6th minus 36. And that's with FOIL, and that's with like showing every single step here. So kind of took over here. Now, if we're just using the shortcut, so we have 4x cubed minus 6 times 4x cubed plus 6. And it doesn't matter if you have the plus first or the minus first. All that matters is after the same thing, just opposite signs. So when I have the shortcut, I'm taking my 4x cubed and squaring it. And then you have a minus, and then you take your 6 and squaring it. And so the 4 squared becomes 16. And with the exponents, you multiply those exponents. So 3 times 2 is 6. So we get our 16x to the 6th. And then 6 squared is 36. So we get the same answer, but with less steps in this case, because I showed more work on the FOIL than elsewhere. So question, couldn't you write the second part as minus 24 cubed 24x cubed minus 36. Yes. So on the FOIL part where I have plus a negative 24x cubed and plus a negative 36, yes, you can write those as subtraction. I did not do that in this case because a lot of people, when they multiply out like this, they do tend to make sign errors and may miss that it's a negative 6 or that minus is really a negative. And so by writing them as negatives versus minuses, it really reinforces the idea that when you see subtraction, it's the same as adding a negative. And it helps eliminate sign errors because there are a lot of people that that's where your errors tend to be, is with getting your signs wrong and forgetting that instead of like the minus 6 times 6, they might just do 6 times 6. And so I write it the way that I do with a plus and then make it a negative so that that doesn't get lost. And then I just keep kind of doing that when I'm simplifying to, again, make sure that when you're actually doing the multiplication, you're not losing that sign, because there are people who, you know, when you're learning and if you're not good with your negatives, you might lose it even when you do the multiplication part. So I don't usually turn it back into subtraction until the final answer, just because it does help those that have issues with signs where you might get lost. Are there other questions? Okay, so now we're going to look at the other special type where you have something squared. So we've got 2 minus 2x, and then that whole thing is squared. And so this is the special product that results in what's called a perfect square trinomial. So when you have a minus, it's a minus b squared. Your answer will be a squared minus 2ab plus b squared. And so that formula may not look very intuitive to you. You might be like, well, where does this come from? Why do we have a 2 appearing here? You know, what's going on? So let's follow the FOIL to see what is going on. So when you have 2 minus 2x squared, to FOIL it out, you need to actually write it twice. So that's what that exponent means. So we're going to write it as 2 minus 2x times 2 minus 2x. So first, 2 times 2 is 4. And then outside, 2 times negative 2x. So that's a spot where someone might make a mistake and not write the negative. So this sometimes it helps to literally write that down so you don't lose that negative when you're doing the multiplication. So I'm going to just write that because that is one spot where somebody might miss that that's a negative. Then we've got our insides there, negative 2x times 2. Again, I'm going to write that out just because of the sign errors that might happen. And then we've got negative 2x times negative 2x. So negative 2 times negative 2 is positive 4, and then x squared. So another reason that I've specifically written it this way is so that you can see how it's getting to the shortcut. And actually, let's just write the whole thing here instead of this multiplication. So this was negative 2x times negative 2x. Let's just write everything out. And this was 2 times 2. So to kind of put it into our form here, just so you can see where the shortcut comes from. So this is equal to 2 squared right here. And this is equal to negative 2x squared. Because you've got negative 2x times negative 2x. And notice that the insides here are the same thing. They're written in a different order, but they're the same thing. We have 2 times negative 2x and negative 2x times 2, but those are the same thing. And we have 2 of them. So we basically have 2 times negative 2x. This is almost a bad example because I have so many 2's here. I should have picked different numbers. I was just making up numbers. Let me see if I can color code to kind of make this easier. So let's say that this is going to be yellow. So I've got a yellow squared here, and then that's where this comes from. And then, well, our 2x, say, is blue. And so our negative 2x is right here, and that comes right here. And then that 2 in the front is because we actually have 2 of them that we're adding together. But if you look at it this way, you can see how this kind of matches our shortcut, our formula. Now the formula has a minus 2 times a times b. And that minus comes because it's a minus 2x. So that's why we end up with that minus there. So I just want you to notice the form of the FOIL and how it really does go to that form of the shortcut of a squared minus 2ab plus b squared. But normally if you're going to FOIL, you're not going to write any of this kind of stuff down. That's not something that you do. You would just go through and multiply these. So we'd end up with 4 plus, and then this will be 2 times negative 2 is a negative 4x plus negative 2 times 2, another negative 4x plus, and then negative 2 times negative 2 is a positive 4x squared. And when you add these, you end up with 4 minus 4x is minus 8x, and then plus 4x squared here. So that's FOIL. Now, when we're using the shortcut here, we have 2 minus 2x squared. And I'm going to color code it like I was kind of doing up here. We're going to color code. So A is going to be 2. And then B is going to be 2x. We're going to ignore that sign in between there, that minus. We're just going to be looking at our formula that we have in that upper right and kind of color coding it. So when you're following that formula, A is 2. So we're going to end up with 2 squared. And I'll do that squared part in a different color. Then we have minus 2 times our A times our B, and then plus our B squared. So A is 2, so I'm just going to kind of plug that number in. And then B is 2x, so I'm going to plug that number in. So I'm just following my color coding with my formula. So if you find letters confusing, which a lot of people when you're learning algebra find all these letters confusing, you can just think of it in colors as well, and then just match your colors up in the positions and where they go. And then you just do the math. So 2 squared is 4. I have this minus 2, and then 2 times 2x is 4x. And then 2x squared, you square the 2, which is 4, and you square the x, so that's x squared. And then we end up with 4, and you multiply minus 8x plus 4x squared. So it's the same answer. So on the left, if you're going to FOIL, you have to multiply it, you have to write it twice, and then go through the FOIL process. On the right, if you're using the shortcut, you don't have to write it twice. You just have to make sure you're putting all of the numbers in the correct spot with your formula, and then you're doing the math from there. Now, either way here, using FOIL or the shortcut, I see people making the same mistake, which is they want to turn it into a difference of squares. They skip the middle part and they want to do it something like this where they multiply the first things and the last thing. But it doesn't work that way when it's identical. It only works that way if you have two things with opposite signs. Here you're multiplying the same thing. So you do have that middle term. So if you're skipping, so you want to be very careful that you know which rule to use when, because the most common error is doing this when you were supposed to do this, you know, not being able to keep apart the two different types, the difference of squares versus the perfect square trinomial. Are there questions? Does this week's material seem easier? I think some people might disagree with the absolute value stuff. Usually that seems to be the hardest part of this week, but yes, I would say that the rest of the things, definitely the operations on polynomials and that does seem to be a little easier. The quiz flips that. Well, the quiz is taking questions from, I think I have it written down, the questions on the quiz for week 2. Yeah, I have everything mapped out. So some of the questions on the quiz are coming from the textbook and not necessarily the exam, like the problems themselves are on the homework. Like some of them are exactly the same as on the homework, just different numbers or letters. But several of them are very similar to homework examples. or not homework examples, textbook examples. So that's something to, but it is, everything that's on the quiz is also covered in the homework. It's just, you're going to get different variables, different numbers, different variations of it. Yes, and the optional work does help a lot. So yes, I would say for this week, reviewing the textbook would be more beneficial than the homework, because the textbook has a more different types of examples than the homework. Because on the homework with factoring, you're limited to 5 questions, but like in the reading in the textbook, there's more than 5 examples. So yes, for this particular week, definitely the textbook examples are going to be more helpful. Some weeks are different. So week 3, most of it's coming from the actual homework problems. So, it kind of depends. So, yeah, so just tips on that. I do have one more using this shortcut. If there aren't any questions on this particular example, if you think this stuff is easy, that's good, because because it really does show up a lot in the rest of the class. So you're going to be doing this next week and then with solving. So it's going to be like doing this with extra steps added on. It's like every week you're adding on some extra steps. I don't see any other questions. So another one, again, this is a little more complicated. Not easy, easier than week 1. That's really interesting. Maybe it's just because you got used to what you needed to do. So week 1 seemed difficult because you're like trying to learn the program, but once you're in the program, you're like, oh, this isn't bad. That's a possibility. Anyway, so, okay, so I'm getting distracted here. We've got x squared plus 4, and then this thing squared. So when you have a plus, the formula is almost exactly the same. So you have your a squared, you have your b squared, but now the middle is going to be 2 times a times b. So when it's a minus, it was a minus 2 times a times b. So here it's a plus, so it's going to be a plus 2 times a times b. So that's going to be the formula that we're going to use. It's very similar. It's just, that sign in the middle of your parentheses dictates. So if I get my highlighter out, this sign decides what the sign there is. And then I will just color code this, because I know when we use the formula, we're going to want it color coded. So I'll just do that right now. So we'll FOIL this. And you are welcome to FOIL on your own on paper and see if you get the same answer. That's good practice. So we've got x squared plus 4, that whole thing squared. So that means it gets written twice. So FOIL, we're going to do the first, x squared times x squared. And that's x to the 4th, because you add your exponents. Then outside, x squared times 4. So that's just literally 4x squared. Then inside, 4 times x squared. It's 4x squared. Oops, I accidentally changed back to white. I want to color code that. There we go. And then the last 4 times 4, which is 16. So it's not too bad doing it by FOIL. It's not like it's a lot of extra steps. So we get x to the 4th. The insides get added together. So it's 8x squared. So when you're adding, you don't add the exponents. And when you're multiplying, you add the exponents. And then plus 16. Now, if we're doing the same thing with the shortcut, I'm going to use my color coding here. So x squared is going to be the spot for A, which is in yellow. And then 4 is going to be the spot for B, which is in blue. So I have x squared, and then it's A squared. So you're squaring the x squared. Then it's going to be plus 2 times your A times your B, and then plus your B squared. So it might, if you're going to use the shortcut, it might be helpful to just put all the spaces out and then you fill in with your stuff afterwards. So like the x squared gets written twice. If you're following the pattern, the first and the first 2 are your yellow, your first thing, your x squared. The last 2 are your last thing, the 4. So you can kind of see a pattern there of how you're writing it. And that can help you use this shortcut. So x squared squared, you multiply your exponents, that's x to the 4th. And then I've got 2 times x squared times 4. I can do 2 times 4, which is 8. And then x squared. And then 4 squared is 16. So same answer. So when I am multiplying this out, something like this or like the previous example, I do use the shortcut because I find it's easier than doing FOIL, because when I FOIL, I have to write the thing twice and then you go through. I do use the shortcut here because it's quicker for me. And I use the shortcut with the difference of squares as well, because I know I don't have to bother writing down the middle parts. Now, when I'm factoring, when I'm going the other way around, I often find that when I factor, I do the difference of squares shortcut. But when I'm factoring these type, I don't always use the shortcut because sometimes it's harder for me to recognize it going in the other direction. But if you're able to go in both directions using both shortcuts, that's really, really beneficial. Any questions? I'm going to make a poll if it will let me. Oh, it's making me do it in another window. That's weird. Okay, maybe I won't do a poll. You can just type in the chat. So looking at the example that we have right here, do you prefer doing it with FOIL or do you prefer doing the shortcut? I'm just curious where people fall in this. So you can just type it in the chat because it looks like to get a poll, it's going to be more work than I care to do. Oh no, am I back? Was it because I tried to create a poll? I think my internet is okay. I'm all over. Oh boy. Okay, I'm back now. I think it was trying to create a poll, kind of messed it up. Okay, so we will not do that. Do you prefer doing FOIL or the shortcut with this type of problem? So you can just type that in the chat. So far, we've got 3 people with FOIL, which is totally fine. If you guys don't like the shortcut, you are not forced to use it. So, you know, Shannon said foil until she learns it better. I think that's actually probably a good way to do it, is to do foil until you get better at it, and you kind of start noticing the pattern. And then once you kind of start noticing the pattern because you've done it enough times, then you can shift over to the shortcut. Yeah, so foil, but can do the shortcut slightly. More foil, more foil. How about the difference of squares one? Where you've got your conjugate, you're multiplying two things that are near identical, just different signs. Do you prefer foil or the shortcut on this one? Okay, so we've got one vote for the shortcut, shortcut. This is exactly what I expected, honestly. The shortcut is really great because you skip half the work, but does it really save you on the other one? Yeah, so we've got more votes for shortcut. All right. That is exactly what I expected. So again, you can use either one, but it is worth knowing that these shortcuts exist, even if you don't use it, because it can save you time down the road. Once you get better at this, you can start practicing with that shortcut and it will save you some time. You might say, is it worth, might save me what, 30 seconds or something like that. But if you're, doing a lot of these problems, it does add up. It adds up. So, all right. So that was all I had for you guys. Stop sharing my screen. Do you have any questions? We already briefly talked about the quiz and where you should look for examples on that to kind of help study. Yeah, prefer the shortcut only when you're being timed. That makes sense. Any other comments, questions, things like that? I'm glad to see that there are people that are finding this week easier. So that's good. Yeah, a lot of with the interval notation last week, I know that gets a lot of people, and we do have to do the interval notation again this week. We will do the interval notation again in week 6 and 7. So actually, I think we do it in week 5 as well. We talked about domain and range. So that will come up again. And we do drop the lowest quiz score. If you turn in your quiz work late, I didn't get a chance to grade it yet. But it will for sure be graded along with all the week 2 stuff this week. I spent most of my time after I was done grading just reaching out to people that had missing work. Just to make sure people were on board, especially with Alex. It's like Alex can be so confusing. So that first week, I do a lot of outreach just to make sure that people are doing the right stuff, But I'm glad that some of you are feeling better than last week. So that's good news. So yeah, that's good. So this time, I know I did week 1, I did it at 6 p.m. on Monday, and then I did it 7 p.m. this week. I'm going to just keep it at 7 p.m. just for those that might be on the West Coast. It's a little later for them, so that, if they're West Coast, they have a chance to maybe attend. So every week moving forward, these will be at 7 p.m. And then I'm going to I mean, I could do 8 p.m. my time, but the survey did not show 8 p.m. being popular, which is, it said it had 6 and 7 with the same, and then 9 p.m. the next week just keep going up. Yeah, 7 p.m. Central is where it's gonna stay at this time going forward. Yeah, and for people on the East Coast, I don't want to go too far, so it does seem to be like a good time for those West Coast people that they hopefully would be off work or close to off work or something like that. Oh, 70 hours a week. I'm so sorry. I don't know how you take classes with 70 hours a week. Suppose I could stop recording. We don't